Cheers, everybody. Some great Fanta. That's good stuff. Little good doer here. So, hello. And welcome. That's good stuff. So, got you on the old webcam here so I can show you around. And I guess on the bench today, got some batteries from work. These are these crappy Axion batteries. Switch you to the other camera real quick. Hello. Axiom. These things suck. They basically, if you leave them sit, not even in a laptop, like a few of these I had to recharge. They go flat. I had to recharge these from the factory, like 3 of them. We bought them and they were flat, but that's easy enough to fix. See that? Just poke a hole right there in the end. This is on the side with the connector, and you charge it up slowly. So that's what I've been doing. Might be able to see on the power supplies over here. Yeah, tripod. And fortunately, this thing is manual focus. I've actually got things labeled there. If I can hold it still enough. DP30V58, DPS 5005, and DPS 3012. A little sticky notes, so I can remember them. Yeah. Set to, 11.5 volts there? Not on. Yeah. 200 milliamps. If it's really low, like less than 2 volts per cell, then you might want to do something like 10 milliamps and just let that come up. So yeah, these guys I've all repaired and they seem to be working fine, I think. No, I didn't have to repair this. This is one of the original OEM ones. And that all I had to do is just leave it out of the laptop for a minute, and it worked. This is one of the 6430 batteries, which all the laptops are coming from 18650s to flat cells. So probably from now on, I'm going to be getting flat cells instead of 18650s. But that's okay. I have quite a few 18650s. Might be able to see. Down there, I've got an entire shelf dedicated to batteries. And that's not even it. I've got a box that size filled with them. There's a few flat cells in there, just some other things. But yeah, that's what I'm doing today. Clearing off the bench. The little wires that I use to go in the hole that I poke in the battery, and then I just use either a fuse or a little piece of metal. I don't think this is actually copper. It's just copper plating. Just use one of the fuses and put it in the negative side, because that's connected, so you don't have to poke a hole on the negative side, just on the positive. Let me put these guys away. Clear off the bench, because I'm going to be building something today. No clue how it's going to go. Here. More light in here. This thing sucks. One of my real bulbs. Picked up some bulbs from a thrift store dumpster. One back at my old place. Might be able to see. I know, I'm taking you off. Got 3-4 spotlights. One of them's an actual infrared light. This guy here. 250 watts. Crazy. And all of these work. These guys are, what, 90 watt? Philips 90 watt flood. So, not sure if I'm going to keep these or smash them open. And I've got a couple bulbs down there ready for a fry up on the ZVS. So that's something to look forward to. Yeah. Get on there. There we go. Oops. What did that button do? Hopefully nothing. Check this out. Switch you to the HD cam. Now you're in the light. Huh? So what it is, it's a Dell charger that got completely snapped off. The cord part got completely snapped from the end, but I hot glued it back together, but with a modification. I've got these two terminal blocks. This one is across the positive and negative, and this one is from the negative to the wire. So the negative of here goes to here, and then the wire from the power supply goes to there. That's even one of the newer, the round ones, the slim, I guess they're calling them, even though they're not. And then, yeah, I've got the Rui Dang power meter, 30 volt, 10 amp, I think. And this way I can measure the watt hours that go into a laptop, or measure the power draw of the laptop. And I can measure like how good a battery is, basically, based on its runtime. So like, I know how much the laptop uses, so if I run, normally I use a Intel burn test, and that runs the CPU at its maximum, and that way I can discharge a battery completely, kind of a stress test, and see how long it'll run. And I know how much power it's using during that, at least approximately. There's some conversion efficiencies, but it's pretty much the same. And then I calculate how long it ran the burn test, and that's the watt hours. I know Dell does do a pretty good job in measuring capacity or whether or not it's good or not, but I at least have a actual classification instead of relying on Dell, depending on whether it's actually updated or not. But yeah, maybe this is better. The HD cam. This is my work laptop. So let's see. Oh yeah, I will change the other one because I need to show you something. Hopefully it'll reach, sort of. But over here, might be able to see that a little bit with the orange lights and green lights. That is an actual PoE switch. And that is providing PoE to my package, PAKEDGE, package devices and software access point, which I'm using as a bridge to connect my desktop to Wi-Fi, the Wi-Fi to my jetpack over here. Yeah. That guy. So yeah, that's actually a PoE access point, which is pretty cool. And so it's a 48 volt, 802.11 AT or whatever compliant. It's pretty smart. The chip isn't very big. It's interesting how small it is. 60 watts. If you change it to extend, which like it's only 10 Mbit, whereas otherwise it's 100 Mbit. So that's kind of weird. But 60 watts if it's extend, and 30 watts if it's just normal. Of course, it comes with a tiny 60 watt power supply, but hey, that's enough, I think, for now. Yeah. So the plan is to power that switch with a 48 volt lithium ion battery bank, which should be 14S. So yeah, that's what I think my power wall is going to be eventually. And that way I can run the UPSs straight off of that, because these are 24 or 48 volt UPSs because they have a series, an external battery connection. I'm not sure about that cyber power that I've got running my computer, but at least actually that one might be 24 only, that APC, that gray one. But I do have that one down there, which I had already tried with 12 volts. Well, that's not going to work. And I've got that one there behind. I'm not using currently. This is plugged into that power strip, which is going down to that guy. But that should do 48 volts just fine. So yeah. And then what I'm also going to do, since I have a bunch of there we go. I have a bunch of those two to start. Got a bunch of VoIP phones, VoIP telephones. And you can see there's the input, there's the data going to the Theros chip. But also, it's got 2 bridge rectifiers, a couple capacitors. That's on the output. This is the input here. And a big transistor, switching chip, and a transformer. So, yeah. And then it's got this little sneaky guy, which is the PoE communication chip. So, what I've already done is soldered some wires onto this guy just to make sure it'll work before buying the switch. And technically, I don't need a switch to get these to work because this guy, all he does is disconnects the ground from the rectified. This guy disconnects the ground from the rectified PoE. Positive still goes through, and it measures like surge current and whatnot. So what I did is connected the ground after him and then powered this up by disconnecting its pull-up resistor. Yeah, that would be this resistor right here. Looking to focus on that. But this resistor is actually at a right angle to where it's supposed to be going. Yep. So that's the pull down that this does to disable the power chip. Disconnecting that, power chip comes right on, and the whole thing powers up. So what I'm thinking of doing today is taking off this transformer and rewinding it so that I can get 5 volts from it. So I'm probably going to have to like disconnect these going out. And I'll probably remove these other diodes so nothing else powers up. So yeah. I know, so I think it's got 3.3 volts, which is its main rail. And then it does have a 5 volt, but creating that teeny tiny little trace, not much power. There isn't even a capacitor on the side next to the transformer or the diode. And then it has, interestingly, a like 30 volt output going to that linear regulator. That goes this capacitor in that way. It comes over to here on the LCD. Not sure what exactly that does. So yeah, let's get started. So has anybody joined yet? No. Oh shoot. I forgot to change the tip. Got a teeny tiny little chisel tip there. Not that hot right now. Just started to heat up. Well, that's actually pretty hot. There, just dump it on the circuit board. How about that? Do I want the gigantic chisel? Heck, why not? Let's do it. I'm going to use that later for some big stuff. Alright, so the grays. Ouch, that's hot. 320. How about that? Alright. So, I'll change over to the other guy. You can see what I'm working on. There we go. Just dialing in the focus here. That's pretty decent. Right. Got the other ultrafire. Oh yeah, you guys haven't seen that video yet. I'll be posting that pretty soon, where I take an ultrafire and make it a candle. Okay. Probably the best way to do it is just heat the whole board with the hot air until the transformer falls off. That's going to take some doing. Maybe I should pull these capacitors off first. Now let's flux it up. These are 35 volt capacitors. That's pretty crazy. No clue why they're 35 volt for a 3.3 volt line. That's pretty crazy. Alright. Reason why I'm pulling off the electrolytics is so I don't blow them up. Who's calling me? Hi, my friend. Yeah. I'm busy, dude. Alright, so that should be hot. Wanted to get capacitors off a multi-layer board is to just heat one side and wiggle it back and forth. There we go. There's one to 63 volt, 56 microfarad. That's on the PoE side for sure. There's another one. Now for the low voltage side. This is actually pretty easy to desolder, surprisingly. Normally you get like a computer motherboard and these things are impossible. Yeah, 35 volt, 220 microfarad. Probably get a 470 at that size at 10 volts. Oh my gosh. Go away. I talk to him all the time. It's okay. See anybody in the chat? There I am. Live, where's the chat? There it is. Nobody's in it yet. All right. Bike. All right. I don't need to clean those up. Not putting them in right now. So there are some. Well, I can't see what I'm doing. There we go. There are a couple of these guys, so I'm going to heat from the underside. I'm going to heat up on this side. Hopefully the diode and other capacitors will be okay. Let's go 300C. And go to the bigger end for this guy. By the way, I'm using the Xtronic 6000, 6030, 6040. Which, I don't know, $150 so far. It's lasted me a couple of years. And so far I haven't had to buy any new elements or anything, because this hot air gun came with a spare. This guy came with a spare. And yeah, even my 3010, which is an iron kind of like this, that is this, that came with a spare element too. And I think that one I already replaced. I forget what I did with it, but or how I broke it, but I probably just had it too high, let it sit, and well, it died. And that transformer should just fall off. Whoops. Okay. Now let's try one side. screwdriver. Usually works pretty well. Like it's melting. Move that side's up. Yeah. Let that melt, cool down. All right, and I just gotta work on this side. Wait up. Cook the capacitors too much, or my glass. Last time I was harvesting some resistors. Crack the glass on my workbench. Oops. On you. Got it. All right. So now, got a hot transformer. Yeah, while the board is warm, I'm going to pull off these other diodes. Thought it was warm. There we go. There's one. Now for the 5 volts. All right. That's off. Okay. So, what do we got? A couple things, a feedback winding. Hey, there's somebody here. Maybe it's just me again. Hey, say hello. Hello, it's Prinny. Welcome. Maybe I pop out the chat. Oh, I can see you. Pop out chat. Go. Move that there and that there. Hello, welcome to the stream. Welcome to my lab. Right now, taking apart this, modifying, ouch, that's hot, this PoE board with this little transformer. I'm hopefully going to be able to rewind it and get 12 volts instead of 3.3. So I'll get this sticky tape off. It's a little toasty still. All right, so, the primary or the secondary? Darn it, I did not mark it. There we go. That's why you have multiple. This isn't the same transformer. All right. So why you have more multiples. Just grabbing another PoE board with the same same transformer. I don't know where it is. Dang it. I swear I just grabbed a bunch of them from work, but they're probably in this box under a whole bunch of stuff. So let's meter it. Get the LCR meter here. Let's find which side is the most inductance. I want to say it's marked there. Where's the ground on this thing? Where's the ground go? There. And that far pin. So one of these pins should connect to the rest of the coils. One of these end pins. $17.5 microhenries. 70 microhenries. 22 picofarads. 22 picofarads. Okay, those are separated. That is probably the primary side. Yep. So this would then be the secondary side connected here. All right. I get continuity 5.4, 10.8, 20 picofarads, 22 picofarads. All right, 5 microhenries is a lot smaller than 10. This side is the low voltage side, which unfortunately is under all the primary stuff. That's unfortunate. So I'm going to have to completely unwind it and then rewind it. Oh, this should be fun. So, put it on the circuit board. Yep, it is pretty interesting. Let's cook this transformer and get it to reveal itself. Oh, now Andrew, keep it PG. That's okay. So we're just warming it up to soften the glue that it uses. Ta-da! That didn't take much. Normally people say like, oh, put it in the oven for like 40 minutes or something. Nah, just use a hot air gun. So that popped it open and it's going to be extremely hot. Ouch. Yeah, that's hot. Right, come on, let go. Ouch. There we go, there's a little piece of the... That's an interesting transformer configuration. You can see that. Get you a little closer. But you've got two little sort of circular things there. You can kind of see it, which kind of isolates it a whole lot better. Keeps all the inductance in. So I should grab a note card. Remember the windings. Oop, I just broke that off, didn't I? I really did. Wow, that's a really thin wire. Okay, so let's grab a note card. Put this down. That's probably a little overkill, but that's okay. Hey, power hub. Pencil. Oh, this is my design for the power hub. Do. Let's see, so probably the feedback coil because it doesn't connect to the rest, and it's on the outside, so it doesn't need the most flux coupling or whatever. So we've got, yeah. So we've got pin, which way? And I completely messed it up because the marking was on the side. Oh, 1, 2, 3, 4, 5. Did 1, 2, 3, 4. And 2 is on the outer. 2, 1. All right, so pull off the sticky tape. Oh dear, I'm really gonna rip this wire apart. Dang. Okay. So you might be able to keep that sticky tape. We've already done 1 winding, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 turns. That's a lot of turns. Okay. Next, we have... Oh, hi, Nathan. Yeah, I didn't quite recognize the name off the bat. Did I really not write that down? How many turns was that? That's an epic fail. Keep that sticky tape. Alright, so we want to desolder that. Because I didn't rip it this time. There are two wires in parallel. 18, thank you. And that went out and went that way. I'm looking at it that way. Let's flip this around so that I'm looking at it from the bottom. Yeah, that's there. It's from pin 4 over to 5. 18 turns, and now we're looking at pin 3 going that way with 2 wires, and a little solder on that. There we go. Yeah. There we go. Now I'm going to remember how many turns. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 to pin 2. 9. Where does pin 1 go? Okay. Well, now we're on to the other side, I believe. Oh, okay. I think there's 2 halves of the primary coil, and that was 1 half. Where the hell is that wire go? There we go. So now we're on to the other side. That looks like you haven't seen some long wires. This is a tiny little transformer. You know, like, you know, this size. What do you think of the wire that would be inside? You know, maybe one of these transformers? This is like 10, 20 kV. How long do you think that wire is? Now that would be a long wire. All right. So we're now on to the other side. 4, 5, 6, 7, 8, 9. Whoops. Fail. Let's go from 6, 7, 8, 9, and 10. There we go. Looks like we are starting from 7, going that way. Alright, I'm probably going to break this wire. So don't jinx it. Wait, I've already done that. Okay. I'm going to gently. Problem is, sticky tape is sticky. This is like insulation tape, so it's got this goop around it. Yeah, got it. I think. Ooh, yeah, I got it off without breaking it. Okay. That looks pretty. A little shiny. Okay, make sure I'm not pulling off any other wires. Yep, okay. Alright, so this one is going from 7. Let's desolder this guy. Come on. Let go. Got it. Alright. Sheesh. Dang it. Broke it. Oh. So I'll probably be running short, but this wire I don't need. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40. Wow. That's a lot of turns. That is more turns than the primary. And that is ending on pin 6. It was 20 turns, I believe. All right. This one, if that agrees with the pinout, should be the one for this. No, not really. That doesn't quite agree. That is probably the feedback winding. If this goes on to here, then that's the feedback. Oh. Anyway, we will completely desolder this because that's a really long wire. Comparatively for this guy, at least. Alright, mounted in the grips. There we go. And that wrapped around 2 fingers. Pull it out, give it a couple twists. And it comes out as a neat little bundle. We'll set that aside. That was 6 to 7. Which, I don't know. I don't know the windings on this thing. So, pull off the next layer of sticky tape. Getting at it with the edge of the blade. Razor blade. $18? And those, you know. Well, that's coming off in 2 halves, so that's kind of trash. Okay, we shouldn't need very many layers anyway. Yeah. Wow, this looks like the beefy one. So you can't really see it, but this one looks a little bit thicker than the primary. Alright, so we're going from the next wire. This is doubled up, actually. Same as the one on the other side. Alright. So we're going from 8 around 1 turn, 2 turns. Wait, 2 turns, really? Wow. Okay. 2 turns to pin 9. And get the center. Okay. So it continues. And that's going this way. 1, 2, 3, 4, 5 turns. That's got to be that 5 volt. Yep, that ends. No. Okay, yeah. Negative. Oh, okay, they're in series. Alright, that's interesting. It's a bit weird how they did it. That was 5 turns to pin number 10. So we got this wire, not very long. And then here is where it breaks. It goes to a different pin. You got 2 turns. This is for the 3.3 volt. And then added to that basically is another 5 to get the 5 volts. Okay, and then the last layer is the other half of the primary. So I don't need to touch that because the secondary is completely removed. So there's about 7 turns of the, you've got the negative over here, 2 turns here, which goes to the positive 3.3 volts, and then another 5 turns added to the negative there is 7. Yeah, which goes on to this, which goes out to this 5 volt rail. And then from the positive of this, it links to one side of that 20 turn winding, which goes over here for the 30 volts for that other thing. So actually all of these windings are in series. Huh. Interesting. So now I want 12 volts. Get another sip from my great Fanta. That's good stuff. Okay. So what kind of wire do I want to use? Is that this stuff will only give me 7 turns. And I probably want so if 2 is 3.3 and 5, well 7 is 5, that's 5 over 7, 3.3 over 2. 5 divided by 7, we got 1.7 volts per turn. And then 3.3 divided by 2, 1.65 volts per turn. Okay, since the 5 volt was pretty low in voltage or current, the 3.3 was very high in current. So let's do 1.5 volts per turn. So I want 12 volts and times 1.5 volts. Nope, that'd be divided by 1.5 volts per turn. I want 8 turns. Did I do that right? Let's math. Equals 1.65 volts per turn, 5 or 7 is 0.7 volts per turn. So I want 12 volts divided by X equals 1.5. That's actually, 12 divided by 1.5. So I want 8 turns of wire. How big do I want my wire, and what wire do I want to use? Probably want fairly thick. I don't need really thick wire. That's a really long wire. I think this will be enough. 8 turns of this stuff. And it's probably significantly thicker than the other stuff. Actually, it's probably about the same size. Alright, so let's use some of this. I don't know exactly what gauge this is. It's pretty thin. It's probably the same thickness as the original secondary. But this shouldn't take much of it. What you do is scrape off the end. That way it'll make good contact. Of course, you can burn it with a wire, which I guess I'll do just to get rid of extra stuff. And get a little alcohol in the mix. No, not for drinking. What? All right. That's pretty clean. Give it some solder flux. And then I want to go from pin 8 to 9. I think, yeah. No? I want those last two. there. Is actually the 5 turns? No, that can't be. Is that right? Is that wrong? Oh, right, because I'm looking at it upside down. Those are those two. So it's actually 5 turns for the 3.3 and then an extra 2 for the 5. Uh-oh. So I did my math wrong. All right, see ya. Do-do. It's actually 3.3 there, and then 7. 3.3 over 5, and then 5 over 7. Yep, did that wrong. Am I watching? Nope. So 3.3 over 5, 0.66. Yeah, I thought those numbers were quite off. 0.66 volts per turn. And then we've got 5 divided by 7 turns, 0.71. That's interesting. It's a little more volts per turn. I guess just because of the loading, how much current it's handling. So 0.7, so we got 12 divided by 0.7 volts per turn. So I actually need 17 turns. Okay, glad I got that figured out. Alright, so I want to go from this is, of course, highly experimental. Never actually completely rewound a transformer. Should be pretty simple, though. This wire is probably way too thick, but we'll give it a go anyway. I'm shooting for 17 turns. Which way am I going? from 5. That's the wrong side. Yep, that's the wrong side. Oops. Okay, so I'm going to get my windings in order. All right. Going the other way. This way. One turn. One turn, 2 turns. Maybe 3 turns. Four turns. Ooh, that's been. Five turns. Six turns. Seven turns. We got 9 turns now. 13. 14. We're getting off in the rut now. If we can go all the way around again. Nope, now we're on the top. All right. 1. Oh, let's count this properly. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. 15. 14, 14, this is 15. 16, and 17. And that goes to ground, which is, that was ground. Going to depend right next to it. Okay. What we do is heat that up with the lighter. Ouch, that's hot. Yeah, copper conducts heat pretty well. Did you know that? I'm going to need to heat that just a little bit more. All right. Okay. Making sure the windings are all tightened down. Wrap that around. And snip it off. So we should have 17 turns there. Okay. Use a screwdriver to tighten these windings up a bit more. And give it a solder. Dab of flux. And then that's not taking the solder there. I don't think I cleaned it very well. Should have continuity at least. Now we'll measure it. The fancy LCR meter. Fifteen and a half microhenries. All right, now we got to put on the other windings. A layer of insulation sticky tape. All right, sticky tape is on. Now we rewind the other half of the primary. Let's see, this is going this way, hasn't it? Going the other way? Okay. Yep. Okay. One turn. Two turns. Hopefully this is all going to fit in the transformer housing still. 1, 2, 3. It's the first turn now. Making sure they're all bunched up together. Let's see, 1, 2, 3, 4, 5. Right, 6 turns. Seven turns. Eight turns. Nine turns. Oh, I might have miscounted it. I got wire for one more wrap. Yep. Alright. Does it not quite reach? Does not quite reach. Uh-oh. Hello, J-Rock. If you're still here. I am rewinding the transformer of a PoE power over Ethernet telephone. And I think I don't have enough wire to put this winding back on. I've already done the recalculation and added my own secondary because I want 12 volts instead of 3.3 volts. So I'm going to undo this. I'm putting back the primary winding. Let's see if I go back and then go back forward, I'll have more wire. There's one turn. It is 1 o'clock. My timer is done because I want to know how many kilowatt hours over 12 hours the PoE switch has used. So far it's used 4.5. I think I did it like 10 minutes early. Half an hour early? Oh, okay. So we'll start the timer again for 25 minutes. Yeah. I am timing for 12 hours. And I'm going to read the kilowatt hours that the PoE switch has used powering my access point. And that PoE switch is what I'm going to be using to power a few things. This is why I'm rewinding this transformer for 12 volts. Let's see, so there's 1, 2, 3, this is the 4th turn. Fifth turn, 5th turn. Sixth turn. Seventh turn. Eighth turn. And ninth turn. Yeah. Almost there. Not quite enough. Well, like my primary winding is using up a little bit more space than it used to. So I'm running out of wire room. Alright, so I'm just going to have to improvise a little bit. And add. Let's put that guy on. Need to add a little bit of wire. I'm undoing the bundle that it had. Whoops, broke that wire. Alright, so that's kind of about the length. And give them a twist or two. Bit of flex. Alright, now grab a little piece of wire from my bag of wire bits. That ought to do it. and somehow attach it. Try and make those wires straight. That looks pretty good. All right, so I just added that bit of tab wire onto it. Hopefully that does not short out. Put a tiny piece of sticky tape over that joint. It's actually more like the part that it's crossing over. It's crossing over the top of the beginning of its windings, so I don't want that to short out at all. And that's down. Now we bend this over. Down. Where my pliers go? There. All right. A little bit of solder. All right, so that should now be connected. Uh-oh. That one's going that way. And this one is going this way. Uh-oh. I may have done this wrong. I think this is supposed to go the other polarity. Because the first half of the primary let's see, is going in and down and around. That might not be a good thing. I should be able to check the inductance. The first half of the primary. Half a microhenry and 0.3 microhenries. Yep, that's going the wrong way. Oops. Muck that up. Yeah, it looks so pretty though. Ugh. I've got to take this back off. I could probably leave it, but it's going the wrong way. I'll leave it. All right. Pull that little piece of sticky tape off. One, two, three, four, 5, 6, 7, 8, 9 turns in the wrong direction. Oh well. Now we start going in the right direction. I am still going to go this way. Start spinning around. One turn. That should be fun part. I'm splitting apart now. Oh boy. That's 2 wires. Alright. So now. Yep. One turn. One turn, 2 turns. Three turns. 4 turns. 5 turns. 6 turns. 7 turns. 8 turns. I do not have 8 turns on here. I'm miscounting all over the place. That was 8. This is number 8 or 9, whatever. I actually have enough this time? Yeah, I actually do have enough. I think. Yeah, I do, just barely. Just barely. Alright, so I'm going to pull off that extra wire I added. Okay. Put it on here too tight. Can't get it off. Alright, now we bend this wire. And another. Where it's supposed to go. Hopefully without shorting anything out. Nope, that's definitely shorting out. Alright, that little wire is gone. taking off that wire that I broke originally from the feedback on the primary. And we should be able to line this one after a bit of sticky tape. Alright, there we go. All patched up, and now which way does this feedback coil go? Feedback coil is going this way, approximately 18 turns. What I'm going to do is this teeny tiny, you can kind of see it there, teeny tiny little insulation piece on the start of this winding. That way when it goes by all the parts, it shouldn't be too bad. Hopefully I don't break this wire again somewhere further down. If I don't make 18 turns, I'm just going to do 17. Should be all fine in the end. 1, 1, 2, 3, 4. Here's my timer again for metering the PoE switch, which is what's powering, should power everything. We've got 11 hours and 56 minutes. I was on what, turn 5? 1, 2, 3, 4, 5, yeah. 1, 2, 3, 4, 5. This would be 6. Seven. Okay. And 10 now. 11. 12. 13. 14. 15. 16. Yeah, that's all we're gonna get out of it, I think. And let's tuck this guy under the start of it. Yep, I think that's all we're gonna get. Yep. .047 watt hours. Zero point zero 0.047, well, 1,000 watt hours. So that was it with just a regular switch, and it is 0.059 thousand watt hours and 0.047 thousand watt hours. So that would be 0.059 divided by 12 hours, about 4.9 watts. 0.047 divided by 12. So yeah, saved a whole watt of power. Instead of 4.9 watts, it's 3.9 watts. So PoE is more efficient. But of course, it could just be that the gigabit switch that I had is more power hungry than this 10100 PoE switches. But that's okay. And that's also how you measure average power or something, is to count the kilowatt hours. Now that wire cooked fast. All right, let's solder it. So to measure kilowatt hours or something, you add it up, where you get the start kilowatt hours and then the end kilowatt hours, subtract them, or start from 0, and then measure the amount of time, and then however many kilowatt hours that was after so long, you divide it after how many hours it was, and then you get your watts. Where's my cutters? Well, I'll just pull it. All right. And there you have it. Teeny tiny little transformer. That's been redone. I'll put that on here. Hopefully the foil still fits. Let me add the last layer of sticky tape on the outside. Whoops, I just ripped it. There we go. That'll work. Yep. Got one of my bigger clips. That isn't even gonna work. All right, put these two together. Now I've got to glue the transformer back together. With a bit of super glue. And you can undo super glue, just so you know, with a bit of heat. All right, that's glued. Okay. Well, that's drying. All right. Alcohol can go away. All right, so we're back to this guy. Now, so remove the transformer from here, move this diode, move that diode. We're just left with this diode. And we probably want to pull this inductor off because we don't need the board being powered by 12 volts. That would end quite badly. I guess I can just put the knife in over here. And put it one side. What's hard to do? Probably because the whole thing isn't melting off. That should do it. Crack that side. Crack that side. Back to the other side. Got it off. Yep. Now I just need to figure out this little bit. That should probably take some metering. All right. So does anything over here get crap from that? Use the other meter. It's much more responsive. Yeah, positive. Yeah. Much more responsive. Yeah, I don't think there's any feedback coming in from that. Not from this guy. There. Okay. Maybe I just need to redo the feedback. It shouldn't take much. Well, look at that thing going for. $25 minutes? No, can't be right. $2 hours? All right. So, I'm going to reverse engineer this feedback loop. Seems to use this 5-volt thing and the 3.3. They connect to this little guy here, which is a CGW 2D. The 2D is like off at a right angle. But anyway, thanks for watching. Come in and what am I gonna say? Next time you see me stream, join in, say hello, introduce yourself, and we can talk about whatever. What do you want to know? Batteries, power supplies, transformers? Anyway, thanks for watching. See you later.